Hi there. Right now we are, this is Inner Servant. Right now I'm going to show you how to test if a compound motor is connected in differential or cumulative mode. So right now we have our DC motor connected in a compound motor configuration. So you can see this is our power in, our DC power in. So I'll take you up to the power supply here. So we have DC going from here, follow this wire up to the ammeter here, so we can keep track of our current as when we turn on the motor. And then from the ammeter we go down here to the series winding of the compound motor. I currently have this connected in a short shunt configuration. As you can see here, the series motor comes before the series winding. Series winding comes before the shunt and armature windings. Okay, so in order to test if this is cumulative or differential, what we'll need to do first is remove the shunt winding from the equation. So we'll just take this off of here. Okay, and also remove the shunt from the other end of the armature there. Okay, so now this motor is wired solely as a series motor. So you can see that there. So what we're going to do now is just turn on the motor enough to see which direction the motor is rotating. And because it is in series, I do have a load connected so that we don't make the motor run so fast that it spins itself apart, as can happen with series motors unloaded. Okay. So we're going to turn it on. Okay, and I'm just going to increase the voltage, and we're going to watch the rotation. Okay, so it's now rotating clockwise. So the motor is rotating clockwise. So I'll turn it off. And now we will rewire this as a shunt motor instead of a series motor. So we'll disconnect the series winding. Okay. Oh, we're going to need to extend our cables here a bit. Okay, so it was rotating clockwise. With the series coil in the configuration. So now we have the shunt coil, and that's in parallel with the armature coil. Okay. So now we're going to start it up again and watch the rotation. Okay, so as we can see, it's rotating clockwise again. So what this means is, so configured like this, come on over there, there we go. Okay. So I'm going to reconnect this as a compound motor, and since with both coils, each coil individually made the motor run in clockwise to the way we're facing right now, that tells me that when I connect both of the coils in the same manner, that we will have a cumulative compound motor. So I have both the series and shunt coils connected, as well as the armature winding, so it's all connected. So we can try this, and this motor should rotate in a clockwise direction. And it's rotating in a clockwise direction. Okay, so that's great. So now that we've shown that, let's switch the direction of the shunt winding and see if so that will make this into a differential compound motor. Okay, so I just switched the ends on the shunt coil. So we'll turn this on again. Okay, and you see it moves clockwise again. But it's connected as differential instead of compound. And we can prove this if we disconnect the shunt. We're disconnecting the series coil. Okay. So we've disconnected the series coil, and we're going to attach the connect the shunt coil reverse the way we had it before, and we're going to turn the motor on. Okay, and you can see now it's rotating counterclockwise instead of clockwise. So what this means is, when we had it connected with the series connection, the fields were working against each other. But right now, when I had it set up originally, the magnetic fields were working together, and we had a cumulative compound motor. And so that's how you tell the difference between cumulative and cumulative and differential compound motor.